Hello, AP Chemistry. I'm going to talk you through gravimetric analysis today. You may wonder why I am wearing a winter coat. It is because it is freezing in my classroom, literally 32 degrees in my classroom. The heat broke, and so it is very cold. So welcome to teaching from a hood. Okay, let's talk about gravimetric analysis. I want to introduce you to this concept, and then I want to show you an example of the concept as we go through the practice. So gravimetric analysis is yet another technique we have to determine what's in solution and how much is there. So here's the general idea. Usually you have a sample of some sort of solution, and in the solution you have specific ions that are going to be in there. Let's just call them positive and negative ions for now. So you have a bunch of little ions all floating about. So in gravimetric analysis, usually we know what the ions are. We just want to know how much of them is there. So good examples of this would be like if you are working for the sewage treatment plant in McMinnville, for example, and you want to know how much phosphorus is being pumped out of our sewage treatment plant and into our rivers. So you could do something like gravimetric analysis. There's another example in your textbook that talks about testing the ions that are flowing into your home. So how many of these ions are you eating or drinking? What's flowing through your pipes? How is it going to affect your pipes? So there's lots of different reasons we want to know what ions are present and how much of it is there. So usually in gravimetric analysis, you have your little sample with ions in it, and then you pour other ions in. So we have a sample that we're going to control. We know what kind of ions are in here. And we're going to pour those ions in to this other beaker. Okay, so what we get is a new beaker, still with solution, more solution in it now. And our original ions are still there. Now, we hand select a couple ions to pour in, and what we want to choose are ions that are going to attach to the ions that are already there and form a solid. That is what we call a precipitate. So it's going to form a solid, and then what can happen is we can pour this solution through a filter. So we put a little layer of filter paper down, we pour our solution into it, all of the solution and the free ions that are just floating around. What was our free ions? Our free ions that are floating around will flow through into a new solution. And then the solid will get stuck here. The solid will get stuck on the filter paper. So let's recap. We have an original solution with some ions in it. We hand select a couple different ions to pour in that will attach to the original ions in solution, at least one of them. Then we pour this whole concoction of a solid, a new solid that we just formed, plus ions that didn't form a solid. We pour that through a filter paper. Now the ions that we don't really care about, that we're not tracking, just flow through the filter paper. And then the ions that we do care about, that we have targeted in order to form a precipitate, get stuck in the filter paper. This is gravimetric analysis. We can then take the filter paper We can then take the filter paper, we can dry it so all the water evaporates off. We can, here we go. So here's our filter paper with our little solid stuck to it all over the place. Positive side, negative side. Okay, so that's our ionic compound stuck to our filter paper. We can dry it so that all of the extra water evaporates and floats away. And then all we're left with on that filter paper is very, very dry ionic solid. So we can weigh that. We can figure out what the mass of that is. We can convert that into moles of our ionic solid, and then we can convert that into moles or grams of our ions. And we can kind of back calculate to figure out what is the mass of the ions or the moles of the ions that were initially present in our water. So this is the concept of gravimetric analysis. I want to walk you through the procedure, the practice procedure, so that you can actually see it now. Let's go. All right, here we are at the end, and you can see my jar. Notice that it's not looking super clear anymore, and that's all solid that we want to collect. So again, even though you've just been sitting here for hours waiting for your sample to dry, you want to add a little water and make sure you get all of that solid out and drain through. And this is another important place for you to realize that the amount of water really doesn't matter because it's going to go through our filter. What you really want is to collect all of that solid out of your beaker and get that into your filter paper. So we're going to let this finish drying or finish draining, and then we're going to talk about the drying process. Okay, so our sample has finished draining. Let me show that to you. Ta-da! So we want to dry that now, because if we weigh that solid as it is, we're going to be weighing the solid, the filter paper, and water. So we want to get rid of that water component so that we can weigh this and just have the mass of the filter paper and the solid. So we can leave it overnight and it will just dry by itself. If we don't have that much time, we're going to use a watch glass and a drying oven. So when you pull your sample out, you got to be really careful. You don't want to rip the filter paper. We don't want to lose mass in our solid or our filter paper. Okay, so we're going to pull it out. And then if you keep it folded like this, as it dries, it'll actually protect the solid in here, because as that solid dries, it's going to turn into powder. And every time you move it or the breeze blows, powder is just going to go poof everywhere. So if you close it and lay it on your watch glass like that, it'll kind of protect the powder. And then what we do is we take this and we put it into our drying oven. So this is a drying oven. It's specifically designed to dry stuff. We'll put our watch glass in there. We'll turn it on. And this can track the temperature for us. Now there's a couple considerations when using a drying oven. You want to dry your sample. You don't want to cook your sample, right? We don't want to heat it up so high that it's going to start to decompose on us. The other thing is that could lead to cooking is just leaving it in there too long. It depends on what your sample is, whether it would decompose under heat or prolonged heat. So what we'll do is every 10 minutes we'll check it, and then we also want to break up any clumps, because clumps are going to tend to hide the moisture and it'll take longer to dry those out. So we'll check it, we'll break up any clumps, we'll weigh it, and then we'll keep doing that in 10-minute intervals until it stops losing mass. Once it stops losing mass, we know that we've driven all the water off, and then that can be our final mass of our sample. Actually, before we start drying, let's get an initial weight. Okay, I'm going to zero the weigh glass. .4 grams. Now we'll put it in the drying oven. And we'll check it in 10 minutes. Okay, let's check our sample. So here's your next technique thing. You can't put anything hot on a scale. If you put something hot on a scale, you might actually warp the scale, and then it won't give you an accurate reading anymore. So instead of taking our watch glass out of the drying oven and putting it on the scale, I'm gonna switch watch glasses. So I'll put the cool watch glass on the scale and zero it. And then I'm gonna pull out just what's on the filter paper and leave the hot watch glass in the oven. And it says 3.3. Ooh, that's a pretty good loss. All right, let's put it back in for another 10 minutes. Okay, third check. Let's zero our cool watch glass. Collect our filter paper. Two point three grams. So because our weight keeps changing, we will keep measuring it, and we will keep measuring it until it stops losing weight or maybe gains weight again. Then we'll call it completely evaporated, all the water gone, a true measurement of just filter paper and solid. All right, and check number 4. .9 grams. Let's also take this opportunity to look for some chunks that may need smashing. Make sure we get all that solid back off the stir bar. Make sure we didn't lose any weight. 1.9. Okay. And we'll keep rolling. And data point number 5. $1.9. All right. We'll do one more data point. Okay, let's take a 6th data point and hopefully we'll be good. $1.9. Okay, so we will, since our mass is not changing anymore, we've had 3 data points at 1.9. We are assuming that all of the water has been evaporated out and that 1.9 grams is just the mass of our filter paper plus solid. Okay, now we can move forward and do the calculations.